So this video is on vectors. Let's say that we have these three column vectors. And remember what a vector is just a direction of an arrow. If we start from the origin, this one would go 2 in the x direction and 4 in the y direction. So 2 in the x direction is right here, and 4 in the y direction is up here. And that would be the end point. And then we would draw from the tail to the tip, and that would be our vector. So it has a certain length, a magnitude, and it has a certain direction, which way it is pointing. We can do multiplication, addition, subtraction with vectors. We just will take the top number, the x direction, and the bottom number, the y direction, with each as if, so if we multiply something by a vector, we would multiply both the top number and the bottom number. If we add to another vector, we're going to add the top numbers and then we'll add the bottom numbers. For example, 3 times m would be 3 times the m vector of -3, 2. And all we'll do is multiply the 3 by the -3 and get -9. And we'll multiply the 3 by the 2 and get 6. And so our new vector is -9/6. If we wanted to do something like 2k plus 3m plus 2n, we're going to do our multiplication. We're going to put in each vector for the letter. 2 times the 2, 4 vector plus 3 times the -3, 2 vector plus 2 times the -5, -1 vector. We're going to multiply that 2 by both the top and the bottom numbers. Then we're going to keep the addition and multiply that 3 by both the top and the bottom numbers. Keep this addition, multiply the 2 by both the top and the bottom numbers. Now we're just going to add together 4 plus a -9 plus a -10. I like to add my same signs together, so -9 and -10 is -19 plus 4 will be a -15. 8 plus 6 plus a -2. 8 plus 6 is 14, and then a -2 would make it 12. If we want to find the length of the vectors, we can think of them as finding the distance. So let's say we have the vector 4, -1. That means that we have gone over 4 in the x direction and -1 in the y direction. And there's our vector from the origin. We can make that into a triangle. It was 4 across and 1 down. Even though it was a -1 because we went down, the length of that triangle leg is just 1. So let me draw that triangle a little bit bigger. Again, this side was 4 and this is 1. Well, this is a right triangle because of how we drew it. So we can use the Pythagorean theorem, a squared plus b squared equals c squared, with c being the hypotenuse. That would be the side across from the right angle. And if we want to find c and not c squared, we would just take the square root of both sides, and this becomes c is equal to the square root of a squared plus b squared. So again, with this vector, that looks like the square root of 4 squared plus negative 1 squared. That will give us c, or the length of the vector. 4 squared is 16. Negative 1 squared is a positive 1. So the length of this vector is the square root of 17. Let's say we have the vector 2, 2. From the origin, that looks like 2 over and 2 up. So the little triangle would have a side of 2 and 2. And what is the length of the hypotenuse, or what is the length of the vector? Square root of 2 squared plus 2 squared. The square root of 4 plus 4 is the square root of 8. And 8, if we want to reduce or make this square root more simple or simplified, we can think about what is 8. It is 4 times 2. And we can take the square root of 4. I know that the square root of 4 is 2, so that can come out of the square root. And inside the square root, we are left with a 2. So the length of this vector is 2 square roots of 2, or you might have stopped at the square root of 8. So the length of this first vector is square root of 17. The length of the second one is the square root of 8. That means this first vector is longer. The square root of 17 is more than the square root of 8. What if we have vectors A and B? If we need to find 3A minus 2B. Remember, we take this entire vector, we're going to multiply both of the numbers by the 3, and then we're going to take this entire vector and multiply both of the numbers by 2. 3 times negative 3 is negative 9. 3 times 2 is 6. I'm going to keep that subtraction sign in between. 2 times 5 is 10, and 2 times 4 is 8. Now I'm going to subtract both the 10 and the 8 from the first vector. So negative 9 minus 10 will be a negative 19. 6 minus 8 is a negative 2. Now, what does it mean when our vector looks like this? We're asked for the length of the vector. So remembering that it was like Pythagorean theorem or the distance formula, we're going to say that it is the square root of the first distance, or the first leg of the triangle squared, and the second leg of the triangle squared. 9 plus 4 is 13. Since 13 is not a perfect square, we leave it inside the square root. Let's imagine we have a shape with some points. It's really some vectors put together. This is the A vector and the B vector. And a C vector down here. The vectors have a certain distance, a magnitude, and they have a certain direction. If we would like to express the AC segment in terms of vectors, we know that this is AC, but how do we get there with the vectors? We're going to have to follow A this direction and then follow B this direction. So if we add vector A plus vector B, we would get the line segment AC. What if we want the line segment AD? That's this red line segment. How do we get there? Well, we haven't named this vector, so we have to go along the vectors that we know. So we're going to go along A in the same direction as A, and then B in the same direction as B, and then we're going to go backwards along C. So we added A plus B, but we went backwards along C. Because we went backwards, we're going to use a minus C. Let's imagine that we have ABCD as a parallelogram, and AB is the vector Q, while AD is the vector P. The ratio for AB to BM is 1 to 1. That means that AB is the same length as BM. It's also a straight line, so it's going in the same direction. That means that between BM, we could put the same vector Q. Because it's the same length with the 1 to 1 ratio, and because it's the same direction. The ratio from AD to DN is 3 to 2. So this vector from DN is the same direction as P, but it is 2/3 the size. So we could say that this vector is 2/3 what P is. That means that this whole thing is a whole P plus 2/3 of a P. A whole P is 3 over 3 plus 2/3 is going to be 5 over 3, or 5/3 P. Now, can we write the rest of these segments in reference to these vectors that we are given? dA goes from D to A, which means we're going against P, but in the same magnitude. So that's going to be a negative p. What about MA? Starting here and going along Q and then along Q again, but both in the opposite direction. So a negative Q and a negative Q, or a negative 2Q. What about MN? How do we get from M to N when we don't have any vectors along this orange line? Well, let's go the other way around. So we're going to go opposite of Q, opposite of Q, in the same direction as P and in the same direction as 2/3 P. So for MN, we went a negative 2Q along the bottom, and then we went in the direction of P and the direction of 2/3 P. We've already said that a whole P and a 2/3 of a P makes 5/3 P. So we're going to add because we went in the same direction as 5/3 P. What about B to N? I'm going to go up. If I went up this direction, I could not get from C back over to know exactly what it is to N. So let's go the other direction. From B to N, I can go backwards along a Q, forwards along a P, and forwards along the 2/3 P. So BN was a negative Q because we went backwards, plus a P, plus 2/3 of a P, and again we can combine 1 and 2/3 to be a positive 5/3 P. What about BC? We don't have a vector here, but this was a parallelogram, ABCD. That means that AD is parallel to BC. It's the same direction, and it's going to be the same length as AD. So we can take the vector P and just move it to a different location. It's the same direction and the same magnitude. So BC is also the vector P. The last one is MC. How do we get from M to C? Well, we can go this way against the Q and then up the P. So MC is going to be a negative Q plus P. KLMN is a rhombus. A rhombus has opposite sides parallel and all four sides the same length. We have that KL is the vector M and LM is the vector N. What then is KN? Well, it's a parallelogram, so I can take the vector n and just move its location. Kn and Lm are parallel, so vector n would be in the same direction even over here. And because it's a rhombus, or even because it's a parallelogram, these opposite sides will be the same length. So Kn is just the vector n. What about Mn? It is going in the opposite direction of this vector m, but in the same length. So it will be a negative m. How about Ln? To get from L to N, we can go along vector n, and then against what would be vector m. So a negative m. What about m to k? We could go backwards along vector n and backwards along vector m. So mk is going to be a negative n minus an m. We have this shape ABCD. We have AB as 6 little a and CD as 12 little a. We have a point called X somewhere in here that cuts AB into the ratio of 2 to 1. A to B, 2 parts of it, and then 1 part of it. So about here would be point X. If we're cutting 6 into parts 2 and 1, we have 3 parts total. 2 over here and 1 over here, that's 3 total. So this 1 will be 2a for the length, and this one would be 4a for the length. Now we have a y down here in DC that will cut it into 1 and 2, ratio 1 to 2. So point y is about here. This is 1 and this is 2. In total, we have 3 parts here. 1 part, 2 parts, 3 parts. So if we take 12a and divide it into 3 parts, we will have 4 a's in each part. So 4a for right here, 4a for right here, and 4a for right here. This total would be an 8a. So from D to Y would be 4a, and from Y to C would be 8a. This vector goes this way. This vector goes this way. And we have a vector from B to C that we're calling vector B. We want to express xy as a vector. Well, we can go in the 2a direction, and then in the b direction, and then backwards along the 8a. So 2a plus b, and then minus the 8a. We can combine the 2a and then minus 8a because they are the similar with the a. 2 minus 8 is a negative 6. A plus B. What about from A to D? We need to go around this way with all the vectors labeled. So we're going to go along this one, which was a total of 6A, along this one, which is a total of B, and then backwards along the 12A. So 6A plus B backwards along the 12A. We combine the 6A with the negative 12A, and we get negative 6A plus the B. Explain why AX, Y, D is a parallelogram. One definition of a parallelogram is that the opposite sides are parallel and congruent. This vector is called 4A. This vector is also called 4A. That means that they are parallel, they go in the same direction, and they are the same length or the same magnitude, 4A and 4A. So congruent would be the same length, and they are parallel because they go the same direction. So AXYD is a parallelogram because those opposite sides of AX and DY are both parallel and congruent.